Hi, I'm Ms. Matsuoka, and we're going to learn about how to evaluate logarithms. So we're starting off with this. Evaluating really means finding the value of. So we want to know what this equals. So I'm going to just set it equal to x, because right now we don't know what it equals. So we're going to set it equal to x, and now we're going to put it in exponential form. So we put it into exponential form. If you remember, it looks like this. We're putting it in that spiral. So we have 2 to the x is equal to 8. So 2 to the x power is equal to 8. So now we're just thinking, okay, well, what does x have to be in order for this equation to be true? So 2 to what power will give us 8? The answer is 3. So let me just write that down really fast. X is equal to 3. Let me tell you why that's true. It's because 2 times 2 times 2 is equal to 8. So we got 3 here. I multiplied it by itself 3 times. That's why x is 3 here. Okay, next example. Again, first thing we do, set it equal to x. Now I convert it into exponential form. So 4 to the x power is equal to 1 over 64. And now I'm looking to see, 4 to what power is equal to 1 over 64? That's a slightly harder question, so I'm going to do it a little bit differently. I'm going to make both bases equal. So you might be wondering, wait, what was a base? A base is the number that's not an exponent. So the 4 is a base, and the 1 over 64 is also a base. So I'm going to make both bases 4. So this is 4 to the x power, and I need to make this 4 to some power here. Now 4 to the third power is 64. But this is not 64, this is 1 over 64. And in order to make it 64, I need to flip it over. Whenever I flip something over, it's going to be a negative exponent. So this is not 3, but negative 3. So here I get that x is equal to negative 3. Alright, let's look at our next example. Again, we set it equal to x. We put it in exponential form. And again, I'm making the bases equal. I'm going to pick 2 to be my base. So 4 is 2 squared. It's all to the x power. That's equal to 2. I'm going to put an exponent here of 1. Because anything to the first power is just itself. Now, with exponents, we have these exponent properties, right? And here, when we have the exponents looking like that, they're going to multiply together. So right now we have 2 to the 2x is equal to 2 to the first power. From here, because they both have the same base, you can just set the exponents equal to each other to make the equation true. So 2x is equal to 1, which means that x is equal to 1/2. Alright, fourth example, set it equal to x, put it in exponential form, and again we want the same base. Here's the problem on this one. We can't make the base 8 or 16 because, well, if I try to make it 16, 8 to some power is not going to give us 16, right? Sorry, that would be base 8. So we can't make it base 8 because 8 to some power is not going to give us 16. Can't make it 16 because 16 to some power is not going to give us 8. So can't make it 4 either because even though 4 squared gives us 16, 4 to some power does not equal 8. So we're just going to make it 2. Whenever you're in doubt about what to make your base, just make it a really small number, so that way it will work, like guaranteed. So my small number is going to be 2, 8 is 2 to the third power, and 16 is 2 to the fourth power, but it's 1 over 16. So remember, we need to flip it, so that's going to be a negative exponent, so it's a negative 4. Remember, we multiply these exponents together, so we get 3x is equal to negative 4. And remember, I could do that because my bases are equal, and I divide by 3 on both sides, so I get x is negative 4 over 3. So that's my answer to my fourth one. Alright, let's look at the last example before the bonus question. One last time, I set it equal to x. I put it in exponential form. And now I make the bases equal. So it's going to be 3. I have 3 to the third, all to the x power. And let's see, this is going to be 3 to some power. Well, like I said in my expanding video, the square root is the 1/2 power. So this is 1/2 right here. Again, I multiply those exponents together, and I can set the exponents equal because they're the same base. So I get 3x is equal to 1/2. I need to divide by 3 on both sides. Now when I divide by a number, I'm really multiplying both sides by the reciprocal. So I'm going to multiply both sides by 1/3 really. So I multiply by 1/3, and that really means the same thing as dividing by 3. So I get that x is equal to 1/6. Alright, here is your bonus question. Go ahead and evaluate that. Remember to set it equal to x, and good luck.